A huge number of rogue supermassive black holes are wandering the universe. Supermassive black holes tend to sit more or less stationary at the centers of galaxies, but not all of these awesome cosmic objects stay put. Some may be knocked askew, wobbling around galaxies like cosmic nomads. We call such black holes wanderers, and they're largely theoretical because they are difficult but not impossible to observe, therefore quantify. But a new set of simulations allowed a team of scientists to work out how many wandering black holes there should be and whereabouts, which in turn could help us identify them out there in the universe. This could have important implications for our understanding of how supermassive black holes, these monsters millions to billions of times the masses of our sun, form and grow, a process that's shrouded in mystery, of course. Cosmologists think that supermassive black holes, SMBHs for short, reside at the nuclei of all, or at least some galaxies in the universe. These objects' masses are roughly proportional to the mass of the central galactic bulge around them, which suggests that the evolution of the black hole and its galaxy are somehow linked. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. But the information pathways of supermassive black holes are not clear. We know that stellar mass black holes form from the core collapse of massive stars, but that mechanism does not work for black holes over about 55 times the mass of the Sun. Astronomers think that SMBHs, the supermassive black holes, grow via the accretion of stars and gas and dust, and mergers with other black holes, very chunky ones at nuclei of other galaxies, when those galaxies collide. But cosmological timescales are very different from our human timescales. The process of 2 galaxies colliding can take a very long time, of course, and this makes the potential window for the merger to be disrupted quite large, and the process could be delayed or even prevented entirely, resulting in these black hole wanderers. A team of astronomers led by Angelo Ricarte of Harvard and Smithsonian Center for Astrophysics used the Romulus cosmological simulations to estimate how frequently this ought to have occurred in the past, and how many black holes would still be wandering today. These simulations self-consistently track the orbital evolution of pairs of supermassive black holes, which means they are able to predict which black holes are likely to make it to the center of their new galactic home, and how long this process should take, as well as how many never get there. Romulus predicts that many supermassive black hole binaries form after several billions of years of orbital evolution, while some supermassive black holes will never make it to the center. And as a result, Milky Way mass galaxies in Romulus are found to host on average of 12 supermassive black holes, which typically wander the halo far from the galactic center. In the early universe, before about 2 billion years after the Big Bang, the team found wanderers both outnumber and outshine the supermassive black holes in galactic nuclei. This means they would produce most of the light we would expect to see shining from the material surrounding active supermassive black holes, glowing brightly as it orbits and accretes into the black hole. They remain close to their seed mass, that is, the mass at which they formed, and probably originate in smaller satellite galaxies that orbit larger ones. And some wanderers should still be around today, according to the simulations. In the local universe, there should actually be quite a few hanging around. Our universe, that is the Milky Way galaxy universe. Now, we find that a number of wandering black hole scales roughly linearly with halo mass, such as we expect thousands of wandering black holes in galaxy cluster halos. Locally, these wanderers account for around 10% of the local black hole mass budget. One seed masses are accounted for. And these black holes may not necessarily be active, therefore it would be very difficult to spot. In an upcoming paper, the team will be exploring in detail the possible ways we could observe those lost wanderers. Then all we have to do is find the lost stellar mass and intermediate mass black holes. This has been published on monthly notices of the Royal Astronomical Society, and it's on Science Alert by Michael Starr. Please leave your comments. Thank you for your support.